Let's start now looking at this strange second fact of relativity theory, that everybody measures the same speed of light. We're going to look at an example of how this could turn out and what would be the consequences. So now we are imagining that we have these two brothers, Rocky and Steve. And Rocky is out driving in his rocket, while Steve is sitting in a giant lab watching rocket flying around or out flying in space. Rocky, he is driving at 80% of light speed, and since light speed can be abbreviated c, we can also write 0.8 c, since 1 c would be 100% of light speed, and 0.8 c is 80% of light speed. So this is Steve then measuring the speed of Rocky and measuring that, well, Rocky is driving at 80% of light speed. So now we imagine that Rocky is 4 light years away. 1 light year, that's how far light travels in 1 year, so that's a large distance. But when Rocky is 4 years away, 4 light years away from Steve and driving towards Steve, then he sends a beam of light from the floor up to the roof or to the ceiling to measure how long time does it take for light to reach the ceiling. And Steve is also watching Rocky send this light beam up towards the ceiling. And they're both measuring and looking at it. So as Rocky passes Steve, that's the exact moment when the light reaches the ceiling. And what will be the case then is that when Rocky is looking at, since he's just sitting still inside his rocket ship, he will look at the light beam moving straight up, whereas Steve will see that it started at the bottom of the floor when he was 4 light years away, and then it was in the ceiling when Rocky passed Steve. So it's been going in this slanting light from the floor and up to the ceiling. Now, if they are looking at this light beam and measuring how long it takes for it to reach the ceiling, what will be the result of these measurements? Remember now that they are using light to measure. Steve, well, he measures that Rocky has been traveling for 4 light years at 80% of light speed, and if you travel 4 light years at 80% of light speed, then that will take 5 years, because light, if it moves at 100% of light speed, then light will use 4 years to travel 4 light years. But if it's 80%, then it will use 5 years to travel 4 light years, because 4 is 80% of 5. You can calculate to check that that's right. So Steve will measure that light took 5 years to reach the ceiling, and since light travels at light speed, then he will measure that light has now traveled the distance of 5 light years and used 5 years to travel 5 light years. But we know our Pythagorean theorem, so we know that if this slanting line, the hypotenuse, is 5 light years long, and the line at the bottom is 4 light years long, then it will be 3 light years long, the last line, because 4 squared plus 3 squared equals 5 squared. So we know that, well, if that's 3 light years long, then Rocky, measuring that light travels at light speed, he must measure that now light has used 3 years to travel 3 light years. So to say it once more then, they're both measuring the speed of light. It all makes sense that Steve should measure that it takes 5 years for light to travel 5 light years when Rocky is moving at 80% of light speed. And it all makes sense that Rocky should measure 3 years for light to travel 3 light years, because that will give us then this triangle where everything is in accordance with the Pythagorean theorem. And how does this fit then with the theory of relativity? Well, if we have done both using the speed of light to measure time, the theory of relativity says that everyone will measure the same speed of light, And in this case then, we see that Steve measures that the trip took 5 years, and Rocky measures that the trip took 3 years. And the theory of relativity says that they are both right. And the practical consequence of this is that Steve has become 4 or 5 years older and Rocky has become 3 years older. And what that means is that actually physical processes has been moving slower in Rocky's case. So that chemical and biological processes has made it the case that Rocky has biologically, his body has become 3 years older, while Steve's body has become 5 years older. And we are going to look at various experiments, etc., that confirms that this is the correct result. And so we can also imagine Rocky traveling even faster and aging even less, all the way down to the photons, the light particles that travel at light speed. They don't age at all, they just stay unchanged at all times. And so this is then one of the many strange facts about the universe that follows from the theory of relativity. So this was the first look of some of the results then, and that follows from the fact that everybody measures the same speed of light.